friends, it's Savanna. So today we're going to be talking about superweeds. And superweeds, to put it simply, are just herbicide-resistant weeds. So we'll discuss the primary factors that lead to herbicide resistance. We'll go into a little bit of history on the chemical industry in the US, and then finally discuss the downstream effects of these superweeds. Before we can begin to talk about superweeds, we need to discuss some basic principles of herbicide resistance. Herbicide-resistant weeds, or biotypes, are present already naturally in weed populations, just at very low frequencies. So these characteristics are not common to the population as a whole. Generally, weeds are very genetically diverse and will respond differently to different herbicides. Additionally, different selections of those herbicides will change the population over time. This increases the capacity for weeds to pass on their adaptation and survival mechanism. Natural selection allows the hardiest to survive, thrive, and continue to reproduce. Resistance occurs due to three primary factors. The first is monoculture. So weeds naturally prefer some crops over others, so by growing the same crop year after year, the weeds that are best adapted to compete with that crop flourish, multiply, and become stronger over time. So this higher concentration of better adapted weeds also increases the likelihood that when a pesticide is used, they will already be somewhat resistant to it. The second factor is over-reliance on one herbicide. By using just one herbicide, weeds can quickly develop traits and then genes to become resistant, and then pass those genes down. There has been a focused criticism on weeds that are glyphosate resistant. Glyphosate, or Roundup, is popular to many farmers because it is relatively inexpensive, kills a broad spectrum of weeds, and often controls larger weeds better than many other herbicides. It's also easy to apply. Glyphosate-resistant crops, also called Roundup Ready, are genetically engineered to be resistant to the herbicide Roundup. This gives farmers the convenient option of spraying directly onto their crop, rather than having to apply Roundup to the soil before the crop has germinated or wait to carefully spray it between the crop rows. As a result, many farmers started to rely exclusively on glyphosate. The last factor that contributes to herbicide resistance is neglect of other weed control measures. So many farmers now only rely on chemical weed control methods. Other weed control measures such as cover crops and crop rotations and tillage are not used as frequently. To add even more into the mix, in the early 2000s, the generic product of Roundup was made available to dozens of manufacturers, which subsequently decreased prices. This even further fueled the use of this herbicide and emergence of more and more weed control problems. Did GMOs cause superweeds? No. To be clear, GMOs are not the root cause of superweeds, and Roundup isn't either. Rather, monoculture alongside single-mode weed management strategies fostered the perfect environment for superweeds to flourish. How did this all begin then? The end of World War II produced a technological boom in agriculture. Since the development of this chemical industry, agriculture has become increasingly reliant on herbicides for pest and weed control. Weed scientists today believe that the first problem was that farmers relied too heavily on one chemical for weed management. In the 1970s, it was widely recognized how damaging certain pesticides were, such as DDT. Therefore, the U.S. phased out many of these pesticides. Monsanto's introduction of Roundup and its new line of seeds was a miracle worker for farmers. It was able to kill a broad spectrum of weeds, and also broke down quickly, therefore reducing its environmental impact. So really, the original intent of this was to save farmers time, expense, and make weed control more feasible, which would then lead to greater yield. Initially, Roundup did fulfill this, and it actually made farming a lot safer. Because it was more effective than any other herbicide on the market, a lot less needed to be used. Roundup also opened the door to conservation tillage. So because farmers had this extremely effective herbicide for weed control, they no longer had to plow their fields. This led to a total reduction in the amount of soil that was lost every year. And the option for low-till or no-till offered a tremendous amount of advantages from a sustainability standpoint and a feasibility standpoint. Tilling causes soil erosion and water runoff while allowing greenhouse gases and valuable nitrogen to escape. It also uses more fuel, since tilling requires another pass through the field with a tractor. This degraded soil also needs more fertilizer to make up for that lost nitrogen. This delicate topsoil can then easily run off into our water systems. Conservation tillage also allows the ground to be more productive, hold more water, and allows for better aeration occupied by earthworms and beneficial microbes. As you might have guessed by now, the environmental impacts of superweeds extend far beyond the superweeds themselves. The indirect environmental impacts are mostly associated with the really high need for herbicides for weed control. And often there are many unintended damages done by the manner in which these herbicides are applied. For instance, industrial agriculture demands broadcast applications that are non-selective, meaning that they affect all plants and animals present, not just their intended target. This results in a loss of diversity of the soil, plants, and non-pest species, not only in the agricultural landscape, but its surrounding ecosystems. Greater reliance on pesticides for weed control has lasting and complicating impacts, both socially and economically. One of the most obvious impacts are acute pesticide poisonings and the detrimental effects of chronic exposure. This is difficult to quantify, however, as people may not get sick from pesticides until many years or even decades later. Many of the long-term effects of pesticides are also hard to see because people in farming areas are exposed to many different chemicals. Additionally, many manufacturers continue to claim that their product is biodegradable, having no long-term implications on the soil or surrounding ecosystem. However, many of these products have been found to persist for as long as years in the soil and on sprayed plants, and up to 6 months in the water. The economic costs of herbicide-resistant weeds are from reduced yields and increased production costs in order to combat weed infestations. For instance, in 2010, herbicide-resistant weeds costed farmers an extra $17 an acre due to reduced yields. Georgia and Arkansas cotton producers saw additional costs of up to $19 per acre due to glyphosate-resistant Palmer amaranth. There are a few different programs in the new Farm Bill that should be mentioned related to the issue of herbicide resistance. It included benefits and incentives for no-till practices, and it also clarified the language surrounding the use of cover crops, which better connects crop insurance to soil health. More specifically, the new Farm Bill clarified the definition of cover crop termination and defined cover crops as good farming practice. This will hopefully protect farmers who utilize cover crops from being unfairly subject to losing their crop insurance. While unfortunately the final Farm Bill didn't go so far to make soil health practices as a part of risk management, it did funnel a lot of funding into the Environmental Quality Incentives Program. This reimburses farmers for conservation-oriented farm projects. Additionally, more money towards the Conservation Stewardship Program will pay farmers and offer additional incentives for them to use practices that reduce soil erosion and promote better water quality, such as planting cover crops and altering the way fertilizers and herbicides are applied. In the end, all of these steps towards better weed management strategies ultimately benefit the public. These practices lead to healthier soil, cleaner water, fewer greenhouse gas emissions, and more carbon sequestered in the soil.